In this video, we will be looking at gas laws in two scenarios, both with balloons. Let's say Jeff is walking and he finds a balloon and he decides to pick it up. And he decides to take it and he takes it and blows it up with helium. And while he's blowing it up, it continues to get bigger and bigger. Let's look at why this happens and the relationship between moles and pressure. Let's say the number of dots represents moles. Let's say we start with 2 moles of helium and they're moving around and hitting the walls, called wall collisions, which causes pressure. If we add 2 more moles, inflating the balloon, they're still hitting the walls, but because there are more of them, there are more wall collisions occurring, increasing the pressure. Let's look at the math and N equals moles in this equation. The equation for the relationship between moles and pressure is P1 divided by N1 equals P2 divided by N2. This equation, the starting pressure is 0.0203 kPa, the starting number of moles is 0.001 N, the ending number of moles is 0.15 N, and we are solving for P2. If we plug all the numbers into the equation and cross multiply, and then divide both sides by 0.001 N to get P2 by itself and cancel out moles, and we end up with P2, the ending pressure, equaling 3.045 kPa. Let's look at scenario number 2. Let's say Jeff is holding his balloon and he lets go, and the balloon flies away over a wildfire, and while it heats up, it expands more and more, and then it explodes. This scenario is an example of Gay-Lussac's law. Let's look at why the balloon exploded. When Jeff is holding the balloon, the temperature around it is normal and allows the balloon to stay inflated. This is because the moles are moving at a normal speed and the number of wall collisions are creating a normal pressure. After the balloon flies over the fire, the temperature increases drastically, and when temperature increases, the speed of moles increases, causing more frequent wall collisions, which increases the pressure. As the pressure increases, the balloon begins to expand until the pressure is so great the balloon pops. Let's look at the math for this. The equation for Gay-Lussac's law between pressure and temperature is P1 divided by T1 equals P2 divided by T2. In this equation, the starting pressure is 101 kPa, and the starting temperature is 294.26 Kelvin. The ending temperature is 699.82 Kelvin, and we're looking for the ending pressure, the pressure right before the balloon pops. We plug the numbers into the equation, cross-multiply, and then divide both sides by 294.26 K to cancel out Kelvin, and we end up with P2, the ending pressure, equaling 240.2 kPa.